So chapter 6 is about random variables, both discrete and continuous random variables. In the first chapter we define them and what are they, what do they look like, what does the probability distribution of them look like, and then how to calculate the mean and interpret what that means. Same thing with the standard deviation. And the next video will be about the continuous random variable. So discrete random variables, we'll talk about. Continuous in the next video, are ones that you can, there's a fixed set of possible values, and then you can also calculate the probability of each of those fixed values. So if you can make a tree diagram or an organized list, no matter how complicated, if you can make that happen, then you're talking about discrete random variables. And just like other situations where we're dealing with probability, a couple of the things need to happen. So the probability of each of those values is going to have some sort of number between 0 and 1 to describe its chance of occurring. And when we look at all of the probabilities together, it's going to equal 1. So all of the things together are all of the possibilities with a 100% chance. So unlike all the complicated stuff that we did in the previous chapter, once you have your probability distribution in this, like this table, this one for some reason was a little offset when I printed, all you'd have to do is add the probabilities of the particular values, and that will give you the probability of any event within those. So if we were, example, here we have the probabilities that occur when you flip 3 coins. We did this in class, and so when we look at the conditions that need to be met for the probabilities to be appropriate probability distribution, for one, we add these all up and they add up to 8/8, which is 1. And then also, if I wanted to find the probability of any of these happening, like if I wanted to find the probability that I had an odd number, for example, and I would write that a little different, by the way, for probability of a random variable. We'd write with the large X, and we write what's inside as well, like we normally would, but we write the large X. And so the probability that it's even, I said odd, so I'm losing my mind. I'm talking about the complement here. My bad. The probability that X is odd, once again, big X, big X, big X, is going to be the probability of 1, which is 3/8, and the probability of a 3, which is 1/8. So you have a 4/8 chance of landing on an odd number of heads. We've talked about probability models before, and a probability model for a random variable X is the same type of thing. If you can make your list here you got your list, and we have the probability, the outcomes that have 0 heads, and the outcomes that have 1 head, and the outcomes that have 2, and outcomes that have 3, and then we can go ahead and have the probability of that. A distribution of a random variable is like this table is a distribution. It talks about the value as well as its probability, the value as well as its probability, or we can have it in histogram form. Here's the value, and here's its probability. So a probability distribution works just like any other distribution. We'll be commenting, for example, that this is unimodal and it's symmetrical and all of that stuff. So this brings back a lot of stuff that we've already. When we're talking about the average of a discrete random variable, since we know how much it's worth and how frequently it occurs, all we're going to do, and looks like it's hard to read, but basically what we're going to do is we're going to take each of the values, right? Each of the values, and multiply by its probability. So x1 is going to be multiplied by the probability of 1, and then we're going to add it to the second value and its probability, and to the third value and its probability, and then we're going to add it all up, which is what the sigma means. We're going to add them all up, and that's just going to give us the average. And so since this is a chance process, we're going to talk about the fact that this expected value by the way, the average of x and the expected value of x are synonyms from one another, so either symbolization can be used. The mean of, or the expected value of a random variable x is what we can expect after lots and lots and lots and lots of trials, because law of large number says that we can expect this over a long period of time. We can't expect this average for a short period of time, but for a long period of time. So when we interpret the mean or expected value of a random variable, make sure you are very clear that it's in the long run after lots of trials. So I'm going to give you, using our example from the coins, if we wanted to find the expected value, we would go ahead and multiply 0 times 1/8 and add it to 1 times 3/8 and 2 times 3/8 and 3 times 1/8. So we get 0 plus 3/8 plus 6/8 plus 3/8, 6, 7, 8, 9, 10, 11, 12, 12/8 is, what is that, 1 and 4/8, so it's 1.5. So this mean of 1.5 is not one of the values, but we don't change this. We don't change this. We don't round up. We don't round down. We just talk about the fact that over lots and lots and lots and lots and lots and lots of trials, we would have a value of 1.5 if we were averaging all of those trials. So we would expect over a long period of time about 1.5. And remember, once again, we can also write that question. What is the mean? We can write it as the expected value. So here we have another example of discrete random variable. In this case, x is the APGAR score of a randomly selected newborn. APGAR is a way of ranking the health of a child within the first minute of its birth. And so if we're looking at this particular one, for example, if a score of 6, this probability right here would mean that 38 out of 1,000 babies we could expect to have a score of 6. And we would find that mean by multiplying 0 times 0.01 and adding it to 1 times 0.006 and 2 times 0.007, etc. And then that would give us our average. And in this case, when we're interpreting the mean, we want to talk about the fact that we don't round it. We use this number 8.128, and that means that the average score out of many, many randomly chosen babies would be 8.128. So before we go to talk about the standard deviation of a discrete random variable, I want to make sure you remember what standard deviation means. Always it means the typical distance from the mean from the center, calculated by the mean. And when we're calculating the standard deviation of a regular quantitative data set, we're going to be looking at a data point and we're going to subtract it from the average, and then we're going to square that, and that squaring once again takes away the idea that 10 above the mean would cancel out 10 below the mean. So we square it, and then we're going to add it to the next data set, and that's what the data point, that's what the x2 stands for, and we're going to find the difference from the mean and square it, and continue to add these together, divide by the total number of numbers, and that's our variance. And then we take the square root to find the standard deviation. Standard deviation of a discrete random variable is the same idea, typical distance from the mean, but we're going to calculate it a little differently, because this piece is already going to be taken care of with the probability itself. So once again, the standard deviation is the typical distance from the mean, but with this particular type of data set, where you're given a value and its probability, this piece right there, the value and the probability, kind of works as the total number at that value. So we're not going to calculate by taking the difference of the mean, squaring it, putting them all together, and then dividing by the total number of numbers. Each individual calculation is going to include that divided by the total number of numbers, and that's what that probability is. And so basically how we do this is we're going to take that difference from the mean, like we always do, square it, and then you're going to multiply by the probability at that one. And then you're going to continue on with the next one. We're going to go ahead and look at the second data set right here, data point, and its probability. We're going to take the difference between that data point and the mean, and then we're going to square it, and then we're multiply by the probability of that second value, and continuing on and continuing on and continuing on. When you look at the formula, it looks confusing, but all this means is add up all the differences of the data points in the mean, and then square them, and multiply by the probability. Just add them up. That's all you have to do, because that division, here's the variance, and then we do have to take that variance and take the square root.